Water is a resource that composes the majority of our oceans, 70% of our bodies, and it's a resource that we can't survive without. But what exactly is water? Well, definitively, water, or H2O, is a substance consisting of two hydrogen and one oxygen atoms connected by covalent bonds. Water is what we call a polar molecule. A polar molecule has a partially positive and partially negative end due to an uneven distribution of charge. For water, the oxygen end is partially negative, while the hydrogen end is partially positive. We denote the partial charge using a lowercase delta sign followed by the charge. Due to its polar nature, water likes to interact with other polar molecules. The partial charge of water and the opposing partial charge of a polar molecule form an attraction. Any molecule that has an affinity for water is what we call a hydrophilic molecule. A general note that you should probably know is that the partially positive side of water likes to interact especially with substances containing fluorine, nitrogen, or oxygen. This is because these elements are highly electronegative or have a highly negative charge. These interactions with substances containing fluorine, nitrogen, or oxygen and water are what we call hydrogen bonds. Now it's important that you remember that hydrogen bonds are not the same as covalent bonds. If anything, hydrogen bonds are actually weaker than covalent bonds, but they still provide a strong attraction. The polarity of water and its interaction with other polar molecules gives it a few unique properties. Firstly is cohesion. Cohesion is the attraction that occurs between water molecules. A prominent example of cohesion can be seen in the formation of water droplets. In a water droplet, the cohesive forces between the water molecules allow them to form the droplet because the water molecules are attracted to one another. Another property of water is adhesion. Adhesion is the attraction that occurs between water and another surface or molecule. As we said before, cohesive forces allow the water to form droplets, as we can see below. But the adhesive forces allow the droplets, or the water molecules, to form attractions with the leaf. In general, the cohesive and adhesive forces work together and are responsible for circulating water throughout a tree. As we can see below, the water molecules are brought upwards by the cohesive and adhesive forces. This is because inside the leaves, there are small pores called stomata that allow the water to evaporate out. As the water leaves out of the leaves, it brings along the other water molecules upward with it. The actual circulation is a little bit more complicated, but we can go over that in another video. Another property of water is surface tension. Surface tension exists when the surface layer of water is formed due to the attraction between the water molecules. An example of this is a water strider floating on water. The water strider is able to float on top of the water because the existing hydrogen bonds that exist between the water molecules form attractions that are strong enough to support its weight. Next, water has a few unique heat properties. In water's liquid form, the hydrogen bonds between water molecules prevent each other from escaping. When heat is absorbed, the hydrogen bonds are broken, allowing the water to move around freely as a gas. However, this requires a lot of heat, hence why water has what we call a high specific heat, or energy needed to raise the temperature of the water by 1 degree Celsius. And it also has a high heat of vaporization, or the temperature needed to evaporate the water. Finally, water is what we call a universal solvent. This is because water dissolves more solutes than any other substance. However, due to its polar nature, it will only dissolve other polar molecules. We can see an example of water being a universal solvent to the right, where we are dissolving salt into water. The NaCl dissolves into its constituent ions, Na and Cl, due to the polar nature of water. So what happens if water interacts with a molecule that is nonpolar? Well, firstly, we know that a nonpolar molecule is a molecule where generally there is an even distribution of charge. Because nonpolar molecules lack a partial charge, they have a very minimal electrostatic attraction with water. Any molecule that does not have an affinity for water is what we call hydrophobic. And we can remember that by the constituents of that word, hydro standing for water and phobic standing for fear of. So we can say that nonpolar molecules are scared of water. A prominent example of nonpolar molecules interacting with water is the interaction between water and oil. Here, we see that the oil molecules and the water molecules do not like interacting with each other. So what did we learn in this video? First, we learned what water is. Water is a polar molecule consisting of 2 hydrogen atoms and 1 oxygen atom that likes interacting with other polar hydrophilic molecules. Second, we learned that the polarity of water gives it a few unique properties, such as cohesion, adhesion, surface tension, high heat capacity, and it makes it a universal solvent. Finally, we learned that water does not like interacting with nonpolar hydrophobic molecules.